Hello, your nines. This is Mr. Vincent again. Hope you're all well and staying safe. Today, we're going to be looking at a short revision on energy, all what we've done since the 1st of April to date. I've gone through all the quiz, I've looked at the statistics, and there are a number of questions I found out that most students were getting wrong. And I want to use this video to address these misconceptions and then to put you in a better place before attempting the end of topic test on energy. So, my advice is go through this video completely, study the content, and then before attempting the quiz. The first thing we want to look at when we talk about surfaces absorbing or emitting radiation or reflecting radiation. So we normally talk about a white surface or a dark surface. Now, dark surfaces emit and absorb more infrared radiation than light or shiny surfaces. So dark surfaces are good emitters and good absorbers at the same time. Now, the only thing surfaces are not good at, they are not good at reflecting infrared radiation. So we need to remember that. So emit and absorbing dark surfaces are the best for reflecting its light and shiny surfaces. The next thing we want to look at, which we looked at in April, the early part of this unit, was to talk about convection, conduction, and radiation. Convection takes place only in liquids and gases. And liquids and gases are referred to as fluids. Liquids and gases are referred to as fluids. Conduction takes place in solids only. That is how energy transfers from one end of a metal to the other end of a metal. I don't know how many of you will recall the practicals we did in year 8. We place three metals over a Bunsen burner and place um, paper clips at the other end with Vaseline attached to the paper clips to attach them to the rod. And we were looking at the first paper clip to fall, and that means that particular metal was a very good conductor of energy. That is one of the practicals we can do in terms of checking conduction of energy. It happens only in solids. Radiation happens in vacuum. Of course, on last Wednesday, we experienced the highest temperature so far this year. That is how heat travels from the sun. We call it infrared radiation, travels from the sun right down to us here on Earth. So, radiation is how energy is transferred in vacuum. Then we moved on to talk about energy, sources of energy. We talked about renewable sources of energy. The keywords there are energy sources that are easily replaced or replenished basically in a short time. So, example of those, we looked at hydroelectricity, biofuels, wind, solar power, water wave, tides, and geothermal. You're going to know from this list, you're going to know those who are very unreliable. Wind is very unreliable. It's not every time it is windy. Solar power, you can only use it during the day. You cannot use it at night. Of course, water waves depends on the wind as well. One of the advantages you should know about biofuels, they are carbon neutral. Okay, so a key disadvantage of geothermal is that geothermal can only be used in certain places. Okay, and then the next we talked about non-renewable sources of energy. They will run out. That is the importance of non-renewable sources of energy. That means they are finite resources. We have a limited supply of them. And so examples of those, we have the fossil fuel, that is coal, oil, and natural gas, and then we have nuclear fuels. However, they are very reliable and you can get a large amount of energy from them, especially nuclear fuels. Natural gas, one of its key advantages is that it has the shortest startup time. So when there's demand, like in the evenings when there's demand, they can just start up a natural gas power station. The good news is UK power now is completely free of coal. So in the UK, we currently do not use coal to generate electricity. Okay, so after looking at this one, we go on to this table. It summarizes everything I've just mentioned. You can pause the video at this point and study this table. In fact, you can do that for any slide you wish to study. Just pause the video at that point. You can write things down in a notebook before continuing. Okay, let's move on. So then we talked about physics equations. Like I said in one of my slides, there are 22 equations you're required to recall and be able to rearrange and apply in an exam for the AQA GCSE exams. You've already done in this unit 9 of those 22 equations. That means you've gone almost halfway through. The first one is weight. Weight is a force, its units is newtons. Weight equals mass times gravitational field strength. The units are there. Note the unit of mass is kilograms and gravitational field strength is newton per kilogram. The second equation is the equation for pressure. Pressure is force divided by area. So the unit of pressure is newtons per meter squared. Note the units again. The third equation is the speed distance time equation. Speed in meters per second equals distance in meters divided by time in seconds. You can use the other form to say distance equals speed multiplied by time. That is also fine. Then we talked about gravitational potential energy. E subscript P equals mass times gravitational field strength times height. The units are all there. Then we talked about kinetic energy, E subscript K. Again, it's energy. Energy is always measured in joules. And kinetic energy equals half mv squared. M is mass in kilograms, v squared is meters per second, the speed squared. We moved on from that, we talked about power. Power in watts equals energy transferred energy in joules over divided by time, which is in seconds. Or power equals work done in joules over time in seconds. Power equals work done divided by time. And the last one is the efficiency. The equation for efficiency. Efficiency is energy output over energy input, or if it's in terms of power, you say efficiency equals power output over power input. Okay, those are the 9 equations. Remember all these equations, and you're required to be able to recall them, use them in an exam, be able to rearrange them, make different variables the subject of the formula before using them, depending on the question you have. Now, we want to also talk about conservation of energy. That energy cannot be created or destroyed, but is transferred usefully, stored, or dissipated. Now, so we've talked about energy, the law of conservation of energy, but we also want to talk about dissipation of energy. Energy is mostly dissipated as heat and sound. So all electric devices or electrical devices dissipate energy mainly as heat. Like your car, when you talk about, in the case of your car, it dissipates energy both as heat and sound. We don't really need the sound of the car. We don't need the heat. We just need the fuel of the car to drive the car from point A to point B. But in that process, heat comes in and the sound is also produced. So most times, energy is dissipated as heat and sound. Electricity is supplied as either direct current, DC, so that is through batteries, that is chemical energy stored in the batteries, converts that to run your device, and also as alternating current, AC, which we get from the main supply. And we've got to remember that the main supply has a potential difference of 230 volts and a frequency of 50 hertz. You got to remember that. Now, we also talked about the plug. Key points here: the fuse and the switch are connected to the live wire. The live wire is the brown wire. The brown wire is in the bottom right. So BR, bottom right. We're going to be putting that table shortly. The earth wire is a low resistance path to ground. So what happens if there is a fault? If the live wire becomes loose and is touching the casing of your device, the plug or socket, if that happens, the earth wire carries away all dangerous currents to earth. So we've got to remember what the earth wire can do. The fuse, again, just a quick reminder, if we say we have a 5 amp fuse, if an electricity of 5.1 amp goes through that fuse, the fuse is going to blow off and disconnect, is going to break. And once that there's that break in the circuit, no current flows. So if it's a 5 amp fuse, anything above 5 amp, the fuse will break, the circuit won't, current won't flow in the circuit. Of course, this is the table I want you guys to study. Right, now we want to talk about the cables which carry electricity. They consist of two parts: the wires in the cable, which are conductors, they conduct the electricity. And then we talk about the plastic coating around the cable, which acts as an insulator and prevents us from being electrocuted. Now, we want to talk about conductors. Conductors allow electricity to pass through them. So, for example, metals are good conductors of electricity. However, plastic, wood, ceramics, etc., are poor conductors of electricity. Electricity cannot flow through them easily. However, insulators are materials which do not allow electricity to pass through them, or we call them non-conductors of electricity. So, for example, plastic, wood, ceramics are good insulators. Metals are poor insulators. And lastly, we looked at the national grid. The national grid is how electricity is transported from the power station, whether they've used at the power station, they either use renewable sources or non-renewable sources to generate the electricity, and that is transported to our homes, factories, offices, and so on. Now, a few things you need to remember here. There's something we call a step-up transformer here. And what is the function of the step-up transformer? It increases the voltage and decreases the current. So to save the loss of energy as it's being transferred through the power lines. Now the voltage can be increased to up to 400 kilovolts to transmit it over this power line. And then we get to this second point which we have where we have what we call a step down transformer. Now the step down transformer does the reverse. It decreases the voltage and increases the current. So decreases the voltage, increases the current. So decreasing the voltage to a safe level to enter a home, factories, or industry. So that's the end of the revision. I wish you all the best in your end of topic test, and I say to you, enjoy your halftime break. Thank you.